Hello. Welcome to Chemistry 104, Environment, Energy, and Health. This is our introductory module to our online course. My name is Roy, and I will be your guide throughout this course. I hope you enjoy it, and let's get started. I have been teaching this course for over 15 years, mostly in a traditional class-based lecture and lab format. In recent years, I've begun to do some work online with this course, and this is the first time that I am doing this course, offering this course, as a totally asynchronous online offering. Hopefully you will derive great benefit from this course, and I would be very interested to know how you felt about this course once you are finished. At that point, we will have an evaluation session, and you can give me your views, either positive or negative. I'd be very happy to hear them. There are 5 main content areas we will be covering in this online course. First of all, the importance of chemistry in modern life. You may not realize it, but chemistry touches you everywhere. You can develop a working understanding of the environment, air and water specifically, and how important these issues are to you. Then we will discuss the various forms of energy, fossil fuels, nuclear energy, and other sources of energy that we're working on in our nation to lessen our dependence on fossil fuels. Then we will discuss the importance of good nutrition and health, how to eat well, how to live well, and hopefully the information you will be receiving will help you make better decisions regarding your health. And lastly, we will discuss medications, over-the-counter medications, prescription medications, as well as some somewhat controversial alternative materials such as marijuana. There are several learning goals that I'm interested in that you would develop during this course. First of all, to see where chemistry intersects your life and how new discoveries are made that will eventually impact your life. I hope you'll be able to recognize basic chemical principles that have an impact on the quality of your air and water, because your life depends on clean air and water. And to identify specific sources and uses of energy and how they are used today. Number 4, to be able to understand food labels and medical information that you read in the inserts and packages. I hope by taking this course you'll become a better consumer, a wiser consumer in terms of your intake of food and medications. And then when you hear something on the news or read something on the internet or in a magazine, you'll be able to understand what is presented to you, and not only that, but to interpret what's told you or what you read, and you can discuss it better with other people. And then to interpret your own behavior and habits as they relate to the content areas, and to assess the effects of those behaviors and habits on one's own self and others. There are some non-measurable goals which you will not be tested on, but hopefully after this course there are 2 other abilities you will develop. Number 1 is curiosity. Lifelong learning is an important goal for all of us. It used to be said when you were out of school you were done learning. I've learned in many years of living that that's just the beginning. So hopefully you'll develop a greater curiosity for chemical issues, environmental, energy-related, medical, food-related issues, and you will discover ways to further your education in these areas long after this course is over. And I hope you become an advocate for sustainability, recycling, better use of energy, the wiser use of foods, responsible use of medications in your life and the lives of those around you. In other words, I want you to make a difference. Xavier's goal in education is to help students learn and be able to make a difference in their society. And I hope that that happens for you. And if it does, I'd like to know about it. When this course is over and you begin to make better decisions, shoot me an email. Let me know what you're doing that's different than what you did before. That, to me, is worth this entire course. At this point, I'd like you to hit the escape key after I'm done talking here and read the syllabus, okay, which is on the Blackboard site for this course under syllabus. And after you read it, I will ask you some questions on the next slide. So after you hit escape and read the syllabus, go back into PowerPoint, press slideshow, and then choose from current slide, and you will continue from this slide. Welcome back. Here are 6 questions I'd like you to answer in writing in a word processed document, preferably Word. I cannot really open WordPerfect, by the date you see in front of you. So these 6 questions need to be answered. I will give you a few minutes to read them or write them down, and then I'll continue. Okay, we will now move on to the next slide. Summary of chemistry in our world. We're going to look at how chemistry impacts us at all levels. This is our world. It's called the biosphere. It is our home. Everything that we use comes from this planet, except, of course, the energy from the sun. Our Earth contains all the materials needed for our life. We extract them out of the air, water, and soil, and we use them in our world today. But the resources on our planet are not renewable, most of them. Fossil fuels, ores. We will run out someday. Hopefully we can make decisions on how to use other sources of materials that are renewable, so we do not run out of our necessary materials. Here's some very healthy foods. I hope you have some today for lunch. The question is, are these foods chemical free? You've heard the term organic. Are these foods organic? What makes a food organic? What makes these foods healthier than a big fat donut? We'll talk about that as well. Chemical reactions are the basic for everything that goes on. Your body is one living chemical reaction. And as such, we need to look at chemical reactions. We will not study them individually, but as we need them, we will invoke them. In this situation you see here on the left side is a piece of metal in a test tube of liquid, an acid. As the metal sits in the liquid, it begins to react with the liquid. The metal dissolves or corrodes, forms a new solution, forms gas. You see it above the level of the liquid, and you get a chemical reaction where one substance reacts with another substance and converts it into yet another set of substances. All the atoms that were in test tube A must be accounted for in test tube B, but their form and identities have been changed. That happens throughout your body, throughout the environment, in everything we consume. This is a rather complicated slide, but it shows you all the natural sciences. And you see, fourth from the left is chemistry. which has input from astronomy, geology, physics, and of course, to really study chemistry, you need mathematics. In this course, we will not use a lot of mathematics, not much above basic add, subtract, multiply, and divide. Chemistry can be subdivided into, that circle there, different disciplines within chemistry. We will touch upon many of them as we go through these courses. Across the way is biology, and the sciences that biology encompasses. Biology interacts with chemistry as well, and most of life that we're going to study really is biochemistry, especially when it comes to food, nutrition, and medication. Here is a blow-up of the left side of that previous slide, showing you chemistry and the way it is divided into different disciplines, sub-disciplines really. Down below here you see organic, inorganic, physical, analytical, different branches of chemistry which chemistry students study as they go through their 4 years of college. Again, we will use what we need from each of them in a simplified version to discuss the concepts in this course. Here's biology, blown up as well. And you see the different subdivisions on the bottom. And again, we will use the ones that we need in order to discuss the concepts to be presented in our course. Then, of course, the bottom line of most material is DNA, genetics. We will not discuss genetics to any great degree, just as it is needed to discuss another concept. DNA is a complicated subject, and we will leave it pretty much for those of you who like biology. You can do further independent study on your own to really get a good idea of what DNA is. But we all know what milk is. Even if you can't drink it, you know what it is. Milk looks like a white liquid, but really it's not. It's actually a mixture of materials dissolved in each other and in water. So a good question to you right now to think about for a minute or two is, what is milk made of? What types of materials? So what are your thoughts? Proteins, water-based materials, minerals, fat? Yes, yes, and yes. We live in a world of rapid technological increases and advances. You'll notice this person climbing up this rock wall has an artificial right leg. 50 years ago, he'd have been in a wheelchair. Today, this gentleman can use that leg like his other leg and do whatever he wants. We live in an amazing world where new discoveries are made every day and they are applied to improving our standard of living and our health. Then there's that iRobot. Instead of pushing a vacuum cleaner around your house, you can let this little guy go, and at certain hours of every day, this machine, if you will go around and clean your floors. Amazing. No more Hoover vacuum cleaners for me. Here's a chart showing us how long it takes to go from the conception of an idea to its realization, to when it's on the market. I'm not going to read all these for you. You can do that for yourself. But notice as you go from top to bottom, the incubation interval, that is how long it took to go from conception to realization, drops. The time to develop the product is shorter as you go down the list. Notice the bottom of the chart. Medical X-rays. It took Madame Curie only 30 days to go from the idea of an X-ray based on Becquerel's accidental discovery of the fact that X-rays can illuminate your bones on a screen, to the first X-ray machine in January of 1896. 30 days. It took photography 56 years to go from idea to the first daguerreotype. Even the Post-it note took 3 years for 3M to develop. The Internet took 5 years, whoever invented it. And even a Blu-ray disc that most of you probably use in your entertainment devices, 6 years to develop. So you can see that some innovations took decades, while some just took days. This slide represents an oil spill. When the Exxon Valdez crashed on the shore of Alaska in, I think it was 1986, millions of gallons of oil were released, and every type of life was impacted. Plants, animals. When the Blue Horizon blew up in the Gulf of Mexico in 2010, similar sites were seen along the Gulf Coast. Definitely, an issue we have to deal with is when our innovations, our fuels, get away from us, and we have, quote, accidents, nuclear accidents, such as when the tsunami hit Japan last year. Massive damage to the reactors. And the effect of that will have on people, we really don't know yet. Time will unfortunately have to tell. Injectables. So many materials are injected into our bodies, good, bad, and otherwise. Vaccines, penicillins, many, many other materials to keep us alive or help us fight an infection or deal with an illness are delivered to us through this little needle. Whether you're afraid of needles or not, they are an important part of medical work today. This table shows you different activities that, if followed through on a regular basis, will deduct 1 life per million. In other words, a person smoking 1.4 cigarettes every day will increase the risk of dying by 1 in a million. You see the list. Many things are accidental. Riding a car, flying in an aircraft, riding a bicycle, canoeing. But these risks most of us take because the chances of them impacting us in a negative way are very, very low. We will talk about a lot of these as we go through the course to give you a better perspective of the risk-benefit issue. And here we have a beautiful, beautiful scene, Crater Lake, Oregon. But sitting on the hillside by the lake, in the black circle, is a pile of water bottles. This is an actual photograph. It was not photoshopped. People who were here visiting left their water bottles in a pile. How long do you think it will take for those water bottles to disintegrate? We'll talk about that as well. Now, there's a module for you to do in association with this set of slides. You go on Blackboard, you go to Module 1, and that is what will be the deliverable for this module, this set of slides, to be emailed to me by the given due date. Thank you. When you are ready, there'll be another module for you to view and to work on some days from now. That will all be given to you at the proper time.